Hello, everyone. So we have another AIME problem. So this is 2023, AIME 2, number 9. So it's a really nice geometry problem. Actually, we are gonna see how important the power of points is in this problem one more time. Okay, so we are given two circles, and then they have intersection at 2 points, which is P and Q, and their common tangent line closer to P intersect those circles at A and B respectively. Okay, so let's kind of see a figure. So I'm gonna have a circle, okay, and then we are gonna have another circle, and then the circles will have intersection at P and Q. Okay, I hope this figure will be good enough to see how that looks like. So let's call this guy is the circle 1, and okay, let's say this is 2. And the circles are intersecting P and Q. Okay, so let's call this is P and this is Q. And their common tangent line closer to P, which is like somewhere right here, is intersecting the circles at A and B. Okay, let me go ahead. So it will be something like this. Okay, and then we are told these tangent points are A and B. So this point right here is A, and this point is B. And the line parallel to AB, okay, that's the line. And then we are going to have another line parallel to AB, passes through P, okay, that will be passing through this point, intersect the circles at 2 other points, X and Y. Okay, so let's try having another point. So it will be something like this, I guess. Okay, and then we are told this line and this line are parallel. And we are told this is X, and this is Y, and okay, so we have Px is 10, so let's write it as well. So this is 10, and Py is 14, so this is 14. Pq is 5, so that distance is 5. Okay, so there are lots of information, but let's see what we are trying to find. And the area of the trapezoid XABY. So XABY. Okay, so we'll connect these guys. So we know the AB and XY is parallel, so we probably need to find AB and as well as the height. Okay, and then there's a 5 is going on right there. Okay, so far I guess it's not too bad. So since this is a tangent line, and let's take my center point and connecting this to the tangency point, so that usually helps, and then I'll do this as well. Okay, and then since this is the radius will actually be perpendicular to the chord, so and then we'll be intersecting at the middle, so that will be 7, that will be 7, this is 5, and this is also 5, and we do need this guy, which is we don't know yet, so these are 90s. Okay, so this is given somehow we need to use this guy, right? And also we need to know the AB as well. So which is why I feel like it's better to extend the maybe PQ. So let's do that. If I extend this way, so they will have intersection at some point right there. So I'm going to call this point as T. So if you remember the power of points, which is really important, I guess, to see right now, because we have, let's say this point like TP, let's call this guy is X. So this is a distance between this point T with this circle first intersection, and the distance between T to second intersection is this X and X plus 5. And the distance between this point to this another intersection of the circle is this guy. So if you remember the power of points, so that basically TB squared, maybe I should have kind of remind. So power of points is like we have a couple of ways. Like one of them is if the lines are intersecting outside, the other one is intersecting inside and stuff like that. Or one of them is tangent, the other one is just secant line. So something like that. So let's say this is T and call this is a tangent. If this is X, okay, and then I'm gonna call this is A and this is B. Parallel points, one of the ways is the square of this distance, okay, so let's call this is k. So square of this distance, x squared, is equal to first distance from the point to the distance from point to the circle, and distance between the point to the other point, like the intersection with the circle. So that's TA times TB. And this is called power of points, but there are a couple other ways, but this is just one of them. So if I use this now in this problem, so x squared, which is TB, actually, TP, this was P. So let's take this guy out of the way. So the square of this distance, actually, this was TB, that was correct, actually. So TB squared is equal to x times x plus 5. Okay, and also, you know, the same thing happening right here, AT squared. So if I take this circle, so this distance squared is equal to this distance times this distance, because that will be the same idea with the other one. So from here, so we can say the left side are going to be equal, which means TB and AT are equal. So AB is actually split into two equal pieces. So this piece and this piece should be same. That is good because we know this part was 5, this part was like 12. So that is like, 7 in total, 12. So which is why this is 6 and this is also 6. So far, so good, because we were able to at least get this guy. So only thing that we need is the height of the trapezoid. So if I know that one, so we will be done with the question. So now maybe it's better to use, you know, this is 6, this is 5, but this figure is kind of smaller. So I'm gonna make it a bit bigger. So let's take a look at right here. So we have AB, and then I have this guy. So something like this. So this is A, this is B. That was a point like this guy and this guy. So this distance was 12, right? And then we have a line passing through this point to T. So, but it's kind of closer to the left side, and this is right in the middle. So it was something like this. And then we know this is 5, this is 6, and this is 6, and this is 6 as well. So what we need is this distance, which is my height. So I can make a right triangle, so I can actually get that guy as well. So if I drop the altitude from this to the other side, you know, you do get a right angle triangle. Since this is 5, this is also 5. So this piece will be 1. And I do know this was X, which is I don't know yet, right? But you know, we did get the TB. So if I go ahead and plug this one right here, so I can actually get 6 squared, which is 36, equal X times X, which is X squared plus 5X. And if you saw this equation, this is actually factorable. So X squared plus 5X minus 36 is 0. So that's gonna be X plus 9 and X minus 4. This is equal to 0. So X should be 4, not negative 9. So X is 4, so which is this guy, right? And now we have a Pythagorean, so that will be root 15, which is my actually height. So that's also root 15. So now we got the height, and then we know the two sides of the trapezoid. So the area will be just 12 plus this guy was 10. This is 14, 24 over 2 times root 15. Okay, so that's 36 divided by 2, which is 18. 18 root 5, 15. So if you add those two numbers, because we are told the area written in this form, so that should be 33, okay? So I hope that makes sense. So it was a powerful application of power of points. So if you don't feel good about it, so it's better to review as well. But that was the number 9.